Projectile thrown horizontally from a height. I am Datta sir. I am an IIT JEE faculty for a long time and also an ex-senior professor of a #1 IIT JEE Institute of India. I am making videos on very small concept of physics for the benefit of IIT JEE aspirants. If you are benefited by this video, please like it and share it as much as you can. Also, since I will be making this type of video on a regular interval, please subscribe to this channel and press the bell icon. You can also give your comment so that I can know what other concept you want. So, let me start. Today's concept is projectile thrown horizontally from a height. See, here there is a point B at a height h from ground, and from that point some particle is thrown horizontally with a velocity u. Now this particle, as it is thrown, it will be affected by g downwards, so that it will have two components. One initial component is u horizontally and the vertical component initially was 0. But by the effect of g, the vertical component will increase with time, but horizontal component will remain unchanged because it is at 90 degree with the horizontal. So if at any point P we resolve the two components, say Vx and Vy, we will get Vx equal to u because u remains unchanged. But Vy will be, actually formula is u plus at. Now u here will be 0 because vertical component was 0 initially. Then and a is g here, so it will be 0 plus gt, means Vy will be gt. That means the two components will be, one will be u, another will be gt. Now this gt component increases with time because time is not a constant. So at any time, if I ask what is the velocity of the projectile at time t, then the v will be root over vx square plus vy square, or v will be root over u square plus g square t square, because vx is u, vy is gt. Now, if we have to find the flight time is capital T. That means in this time, horizontally it moves to OA, but vertically moves to BO. That means vertically it moves by a height of h. Now we can apply h equal to half gt square because initial velocity vertical was 0. So ut plus half at square formula we can apply, and we can write h equal to half gt square. So by this t becomes root over 2h by g. So this is the time it will vertically fall from B to ground, and in this time it will also shift from O to A, so that it will take a curved path and reach to A. That means this is the flight time. This is the time in which it is falling. Now if we have to find the range, what is range? Range is horizontal displacement, and in what time? In time t. That means horizontal displacement in time t will be by velocity u, because it is a constant velocity horizontal. So it will be u into that time. That means u into root over h 2h by g. That means if I take everything inside root, it becomes 2u square h by g. So that becomes the range. Now at A, when it is falling on the ground, then also the two components are there. One is u, Vx is always constant, so Vx is u, and Vy is g into time. Here time is time of flight, because after time of flight it will fall to A. So that means Vy will be g into time, that is g into root over 2h by g, which becomes root over 2gh. So that means Vx become u, Vy become root over 2gh when it falls at O. So at that time, what is the total velocity? That becomes V equal to root over Vx square plus Vy square. That becomes root over u square plus 2gh by squaring these two and adding. So we get the final velocity at which it will fall on the ground. Also, we can find out the angle with which it will fall on the ground with the final velocity. The angle is, if it is theta with the ground, so it is nothing but tan theta equal to Vy by Vx. Tan theta is Vy by Vx. Vy is root over 2gh and Vx is u. So if we divide these two, we will get the angle with which it falls on the ground. So we get here the flight time, we get the range, we get the velocity at which it falls on ground, we get the angle at which it falls on ground. And at any time t also, we can find the velocity by v equal to root over vx square plus vy square. That means root over u square plus gt square. Similarly, at any time also we can find the angle with horizontal tan theta, that will be Vy by Vx. So we can do that. So this is all about projectile thrown horizontally from a height. It can be thrown from the end of a roof, it can be thrown from a tower, it can be thrown from any height, but the condition is it is thrown horizontally. So it will be also a parabola and the path will be as shown in the figure. So this much today. I hope you have understood this. So I will come again in my next video with some other concept. So thank you very much for listening.